So we'll just do a couple more questions with combinations. Again, the key thing on a combination is that the order does not matter. This is important because on your exam, combinations and permutations, and on your test, they're going to be mixed up. So you have to decipher, does the order matter or not? Right? If you have whiteout, that line's not supposed to be there. But as you get into university, sometimes combinations are written like this. Sometimes they're written in brackets like this. So if you had 8, 5, if the 8 choose 5. And then just recently, the last time the IB made a new curriculum for math, they actually changed very, very little in the curriculum. And they were, I think they were worried that not enough people would buy new textbooks. So one of the changes that they did is they changed 8 choose 5 like this to 8 choose 5 like that. In the hopes, I think, that people would be like, oh, we better buy new $120 textbooks so that the students can see this more often. Because on all their new exams, that was the new format rather than the other. Okay? But this n without, oh, did you see I added a line in your notes? You have to squiggle that out. It's so hard not to think of it as a fraction. And I accidentally drew the line in between. It's just an 8 on top of a 5 like that. As 8 choose 5. But we will deal with it this year just like this. You won't see that notation on the exam, but I just wanted to point it out because if you take a university class, you might see that there. Special cases. You have 5 things. You have to choose all 5 of them. How many ways can you do this? So you sit and like, oh, I got to take all 5. There's only one way if you have 5 things and you have to take all 5 of them. Okay? The same thing is if there's 5 things and you can't take any of them. There'd only be one way to do that. Don't take any of them. And choose one, of course, that's just n ways. We saw this in our example, how choosing a group of 6 was the same as choosing a group of 4. Choosing, right, in your deck of cards, we're going to have this number come up, because this deals with poker. For those of you that like poker, a poker hand has 5 cards. 52 choose 5 is how many poker hands are possible in the game of poker. It would be exactly the same as 52 choose 47. Making a group of 47, but that would be complicated and it would be so big to organize. And then you have to be like, well, which cards are missing? That's your poker hand. That would be really annoying. But anytime, right, because how do we do the formula? You always have the number that adds, the bottom 2 numbers add up to the top number. So it shows you why 52 choose 5 would be the same as 52 choose 47, because on the bottom, if they have to add up to the top number, it's going to work out to the same thing. Oh, I kind of gave it away. I knew it was coming. Find the number of 5-card poker hands. $52 choose 5. We're going to do this on our calculator. It's 2.6 million or so. I almost have it memorized, but 2,598,960. So I can show you something amazing right now. 1, 2, 3. Check out this poker hand. We have the 9 of clubs, the 8 of spades, the 8 of diamonds, the 6 of spades, and the 4 of clubs. Are you not amazed? The chances of me getting this poker hand were 1 in 2.6 million. You probably never see this poker hand again in your life. Is it a great poker hand? Yeah. It's like, oh, the 2 8s is like okay, but is it great? No. But the chances of getting this one, probably never see it again in my life, because it's 1 in 2.6 million. But you could say that about every poker hand that you get. You probably never see that one, and maybe that's probably what makes poker a little bit fun, is that it's different every single time. Your chances of getting the same thing are not quite the same. And we'll actually take some time, not today, we'll run out of time, but to figure out, why are some poker hands worth more than others? What are your chances of getting something compared to something else? Committee questions are typical combination questions. A committee of 2 boys and 3 girls is to be selected from a class of 15 boys and 18 girls. How many ways can this be done? So we have 2 decisions that we need to make. We need to decide which boys are going to be on the committee, and we need to decide which girls. So it's kind of got the fundamental counting principle. But then when you say, how many choices are there for boys? Well, the order doesn't matter on a committee, so this will be 15, choose 2. And how many choices for the girls? 18, choose 3. And of course, what do we do with decisions? Do we add in between here, or do we multiply? We multiply. So we have to realize, if it's decisions that are made, you're multiplying. If it's cases, you're going to add. And we're going to do cases with combinations as well. Okay? So one way to decide, when you're doing cases, you've counted something in its entirety. By doing 15, choose 2, do I have the full committee? No, I haven't got the full committee yet. So this isn't cases. This is decisions, and we have to multiply in between. And you can type this into your calculator and get an answer. But I'm sure you can do that, so we'll just go on to the next question. So let's say I decide to take this class. This is actually pretty close. I think we have 22 people here today. This adds up to 20. And I'm going to put you into 3 groups for presentations. Like, oh, doesn't this sound like an exciting thing? Sounds like an English class or a history class. And one group has a bigger job, so they get 8 people in their group, and 5 people in group B and 7 in groups. Do you see that you have 3 decisions that need to be made? Who is going to be in group A? Who is going to be in group B? And who is going to be in group C? How many people could be in group A? Does the order matter? So anybody of the 20 students that are in class could be in group A. I just need to choose 8 of them. Does the order matter? No. Because if you don't like their group and they say, well, we'll put you in, yeah, like if I made groups of 2, I was like, okay, Saint, you're going to be with Kevin. And you're like, I don't like my group. Okay, well then I'll put Kevin with Saint. Oh, okay, that's better. Right? The order doesn't matter. It's still the same group. You can't be like, okay, just move around a little bit. Do you like your group better now? No, we still have the same group. Okay? So if order doesn't matter, that's why it's choose. Now group B. How many ways can I choose group B? Okay? Is it going to be 20 choose 5? No, because 8 people are already in group A. You have 12 people left. and you choose 5 of them to be in group B. Now the people in group A have been chosen, people in group B have been chosen. You're sitting in class and you're like, I haven't been picked yet. I wonder what group I'm going to be in. Hopefully you would realize, but if we need to do the math, there are 7 people left. We have to choose all 7 of them to be in group C. How many ways can that be done? 1 way. Everybody who's left is going to be in group C. And what's fascinating about this, and I'm going to show you this with math, is did it matter that I chose group A first, B, and then C? What happens if I chose C, and then A, and then B? The answer is going to be different. The numbers will be different, because if I choose C first, this is going to be 20 choose 7, not 20 choose 8. And then A is going to be 13 choose 8. Because there's 13 people left, I have to choose 8, and then, okay, we're hoping that the people in group B realize, but they might not. There's 5 people left, you have to choose all 5 of them. For B, there's only going to be 1 way for that. Now, what's fascinating about this is that if I do 20 factorial over 8 factorial, 12 factorial, and 12 factorial over 5 factorial, 7 factorial, and I'm just going to write 1 for that. Even though, oh, actually, you can have 7 factorial over 7 factorial. The 0 factorial comes up in the formula, which is a good reminder for us that 0 factorial is equal to 1. And on this one, if I expanded it, I would get 20 factorial over 7 factorial, 13 factorial, and then 13 factorial over 8 factorial, 5 factorial, and 5 factorial over 5 factorial, 0 factorial. And we do some canceling. You'll notice that these are exactly the same. Do you see that the 12 factorials cancel out? And this is equal to 1, so I'm just going to cancel these out as 1. And here the 13 factorials will cancel out. And we end up with 20 factorial over, doesn't matter the order, I'll write them 8 factorial, 7 factorial, 5 factorial. In both ways, right? Because in the one, the 12 factorials canceled out, and the other one, the 13 factorials canceled out. But you're still left with all the other same numbers. And the answer that we got, does it remind you of an identical objects question? Another way you could have done this is ordered the students from shortest to highest, and then just rearranged and done that work. Okay, this is where we'll stop, obviously.